In this lesson, we're going to look at permutations and combinations, and we're going to focus mostly on being able to identify the difference between the two. Let's first take a look at the formulas used to find a permutation or a combination. A permutation of n objects taken r at a time equals n factorial over n minus r factorial. And a combination of n objects taken r at a time will equal n factorial over n minus r factorial times r factorial. It's important to remember that with permutations, order is important, and with combinations, order doesn't matter. In other words, if we're giving two awards, a first place and a second place, let's say, we choose Jim for the first place award and Carol for the second place award. That's not going to be the same as choosing Carol for the first place award and Jim for the second place award. So the order is very important here. But let's say we're choosing two students to go up and accept an award for a group. Choosing Jim and Carol to go up and accept the award is the same thing as choosing Carol and Jim to go up and accept the award. And that's what we mean by order doesn't matter. Jim and Carol or Carol and Jim represent the same two students going up to get the award. Now let's work through three problems. We'll do one permutation, one combination, and one we'll have to figure out once we get there. How many different ways can you arrange 3 of the 8 letters in the word laughter? Now we know that this is a permutation because if we select 3 letters like L-A-U and we take the same 3 letters and select them again and we arrange them as L-U-A, these are going to count as 2 different arrangements, and that makes this a permutation. So let's grab the formula for a permutation. That's going to be a permutation of n objects taken r at a time equals n factorial over n minus r factorial. So we need to get our n's and our r's. We're going to calculate a permutation of 8 objects taken 3 at a time because we're getting 3 letters. Keeping in mind, here's your n and here's your r. That'll give you 8 factorial divided by 8 minus 3 factorial. And that could simplify to 8 factorial over 5 factorial. At this point, you just need to evaluate. You could use your calculator for this, but it's probably an easy problem to do by hand. Let's take a look. So we'll rewrite 8 factorial as 8 times 7 times 6 times 5 factorial. And then we'll divide that by 5 factorial. So anything divided by itself except 0 is going to give us the number 1. And this gives us 8 times 7 times 6 times 1, which gives us 7/8 or 56, and 6 times 56 is 336. So you can arrange 3 of the 8 letters in the word laughter 336 different ways. Now let's take a look at a combination. 5 students must be chosen from a group of 8. How many ways can a group of 5 be selected? We need to decide if choosing, let's say, Joe and Kay is different than choosing Kay and Joe. And in this situation, there's really no difference between choosing Joe and Kay or Kay and Joe. So order doesn't matter, and that tells us this is a combination problem. So let's get our formula for a combination. The combination of n objects taken r at a time is n factorial divided by n minus r factorial times r factorial. That gives us a combination of 8 objects taken 5 at a time equals, and we have our n here and our r here, so that gives 8 factorial divided by 8 minus 5 factorial times 5 factorial. Now this is going to simplify to 8 factorial over 3 factorial times 5 factorial. And we could use a calculator to do this problem, or we could probably quickly do it by hand. So I'm going to come down here and write out 8 factorial as 8 times 7 times 6 times 5 factorial. I'm going to divide that by this 5 factorial. I'm going to place that here right under the 5 factorial in the numerator. And I'm going to write out the 3 factorial as 3 times 2. I'm not going to write the times 1 because that doesn't change anything. And that makes it easy to say 5 factorial divided by 5 factorial is 1, and 2 times 3 is 6, so we could go ahead and divide it into this 6, and that's going to give us another 1. So our answer is just 8 times 7 times 1 times 1, or 7/8 or 56. So there's 56 ways for 5 students to be chosen from a group of 8 students. We'll take a look at one more problem now and decide if it's a combination or permutation and then solve the problem. Kendall has enough money to buy 4 paintings. If there are 12 paintings total, how many groups of 4 paintings can she choose from? So first you need to figure out if this is a permutation or a combination. Think about 2 paintings Kendall could choose. She could choose a painting of a bird and then a painting of a flower. Now will it matter if she chooses the painting of the bird first and the painting of the flower second? Or would choosing a bird painting and a flower painting be the same as choosing a flower painting and then a bird painting? And I think they're going to be the same. That would make this a combination problem. And a formula for a combination is going to be a combination of n objects taken r at a time equals n factorial divided by, in the denominator, n minus r factorial times r factorial. Let's write this out as a combination of n things, so 12 paintings taken 4 at a time, and that's going to equal 12 factorial divided by 12 minus 4 factorial times 4 factorial. We can simplify that to 12 factorial divided by 12 minus 4 is 8 factorial times 4 factorial. And let's see if we can do this by hand. We'll rewrite this as 12 times 11 times 10 times 9 times 8 factorial over, and I'm going to take this 8 factorial and put it here, and then we'll write out the 4 factorial. So we'll have 4 times 3 times 2, and again, no reason to write the 1. That's going to give you 8 factorial divided by 8 factorial, which is 1. 4 into 12 goes 3 times, and now you could do 3 divided by 3 is 1. You still have the 2 here. 2 and 10 have a common factor of 2, so you could divide the 2 into the 10 to get a 5. And that's going to give you a 1 times 11 times 5 times 9 times 1 in the numerator, which is 495 over 1, or just 495. Now if this is confusing, you can always use your calculator to do the factorial, but hopefully this makes sense. So the answer to this question, how many combinations of 4 paintings does Kendall have to choose from if there are 12 paintings total, is going to be 495 groups of 4. Now you know a bit more about permutations and combinations. See you next time.